All right, appraisers, this is Brandon with Spark for Appraisers, and in this video we're going to be covering the modified quantile version of simple regression that we utilize in our adjustment support tool. Now, we called it modified quantile regression because there is quantile regression, which is primarily for multiple regression, but we wanted to create a version that was for simple regression, which is currently what our adjustment support tool works with. And so that's what we did. We just modified it for simple regression. I'm going to show you how it works. Okay, so first of all, it's called Modified Quantile Regression. What you're looking at is a PDF document that we provide every time an appraiser utilizes our adjustment support tool that goes over every single type of regression. It goes over paired sales, depreciated costs, sensitivity, the survey method, all that stuff. It gives the math, the formulas, so you understand exactly how it works. And we also have a simplified version of this that we provide as well in case you want to load that into your reports to kind of define in layman's terms what it means to the reader of your report. Okay, so I'm showing you ordinary least squares regression here, even though we're talking about modified quantile regression, because our modified quantile regression is simply a variation on ordinary least squares regression. The only real difference is this right here. In modified quantile regression, instead of using mu, we use a percentile, and I'll get into what that means here in a second. But mu, by the way, is the lowercase Greek letter mu that represents the average of the population or the average of the data points involved. So for example, let me just pull up Excel here. If we have 20 different data points, and these are the results for each of those 20, then the average of those, Excel tells us, is 17.05. So that would be what mu is in right here. It would be 17.05. It's the average of all of those x's, basically. Okay, so what are quantiles? Now, quantiles are when you break apart a large data set, like this group of 20 data points, into equal smaller groups. So for example, you can have what's called quartiles. So you can see quartile right here is when you break them apart into 4 equal groups. And that would be this. So if I had those 5 data points, then those 5 data points, then those 5, and then those 5. So we have quartiles. And because we broke them into quartiles, we basically have a 25 percentile right here, the 50th percentile right here, and the 75th percentile right here. And so what that means is prior to here, there are 75% of the data points, and afterwards are 25% of the data points. And if you'll notice, I said right here is the 50th percentile, and that's also the median. So the median is the exact dead center of the data set when it comes to the number of data points, and that would be the 50th percentile. That's also the median. And then if just to give an example, if we talk about quintiles, that's breaking things up into 5 equal groups. So we take these 20 data points. This is just one example here of 20. It could be 21, 25, 128, whatever. Then we break that up into 5 equal groups. And so in this case, it's easy to do because 5 goes into 20 and 4 goes into 20. So we have this. So now we have 5 groups of 4. Now, in our modified quantile regression, we break things up into deciles, meaning we have 10 equal groups. That way we can get the 10th percentile, the 20th percentile, 30th, 40th, 50th, all the way up to the 90th percentile. So basically in this case, because we have 20, we can divide that by 10, and that means each group is going to have 2 data points in it. And so these are the groups. I'm not going to do all of them, but that you get that right there. So you get the 10th percentile right there, the 20th percentile there, 30th, 40th, 50th, and so on. That's what quantiles are. And then here's what we do with that information. Once we have those quantiles broken up and we know what the 10th percentile number is and the 20th, and just as an example, the 50th percentile would be the number. So we have 10 data points here, 10 data points here, the 50th percentile is right here. It's the number between these two. It's the dead center of those 20. So what you do is you take the average of those two numbers. Since there's an even number, that's what you have to do, and then you get 14. So that would be the 50th percentile. If it was the 10th percentile, we would go right here and take the average of these two numbers, and we'd have 4. Okay, so now let's go back to ordinary least squares regression. All right, so in modified quantile regression, all we're doing is we're substituting a certain percentile of the data for the average. So instead of taking that average, which was 17.05, if you remember, shows you right down here, 17.05 is the average, we take the quantile. So 4 if we're doing the 10th percentile, 14 if we're doing the 50th percentile. We pick a percentile and we plug that number in instead of the average of those data points. And that's it. So we basically run ordinary least squares regression using the 10th percentile. And we run the entire thing through. We get the result. We get the R and the R squared. And now there's a whole video I made talking about R squared, so I'm not going to get into it here. Feel free to go check out that video. I'll link to it in the description down below. But essentially, we get the R squared number. And then what we do is we plug in the 20th percentile. And we run ordinary, or this variation of ordinary least squares regression all over again using, instead of the average, the 20th percentile number. Do the whole thing, get the R squared. Then we do it again with the 30th percentile, get the R squared. 40th percentile, get the R squared. 50th, 60th, 70th, 80th, and then 90th percentile, we get the R squared. So now what we've got is 9 different R squared numbers. Now with R squared, the higher the R squared number, the quote unquote better the results. So what we do then is we have these 9 results from running this variation of ordinary least squares regression 9 times. We pick the percentile that gave us the highest R squared number, and that's the result we run with. So if the 60th percentile gave us the best or highest R squared number, then we would run regression with the 60th percentile number here in replacement of the average or the mu, and we get our result, which is essentially the M, or the slope of the line, and that would be the final result from modified quantile regression. So again, just to say one more time, this tool will run this variation of ordinary least squares regression 9 different times, substituting the 10th, 20th, 30th, all the way up to 90th percentile number for the average. So instead of using average, it's going to use the percentile number from 10 up to 90, and the best R squared is the final result. So if the best R squared, again, is 60th percentile, then whatever the slope of the line was from running it that 6th time that we ran it, that is going to be the final result from modified quantile regression. So, and also just to keep in mind, the 50th percentile, which is also the median, can often be the number, and that is actually the exact same thing as running robust least squares regression, or also called robust ordinary least squares regression. So in those cases, those numbers will give you identical results. When the best result from modified quantile uses the 50th percentile, that's also the median, and that's also what robust least squares regression is. Anyways, that's it. That's how it works. Hopefully that made sense. Hit that subscribe button if you want to see future videos like this, and we will talk to you on the next one.